the last presentation, David did a thing on prototyping boards and went through all the various flavours and types of prototyping board that there is. So at the end of that, we had a bit of a conversation and Lochmaster came up, and 2 or 3 people bought Lochmaster and have dipped their toes in it, but haven't really got very far with it. We'll start with the basics about if you don't have it or you want to know about it. It's made by a German company called Abacom. They also make 2 or 3 other products that are quite useful. It costs 50 euros nowadays. I think it cost about 15 euros when I bought it, which was a long time ago. And ever since then, I have still received updates. So I put an update in this in January, February of this year. So if you keep it up to date, lots of little things keep getting better. For example, it used to be that if you put a regulator on a board, you get Eingang and Aufpasst, which is input and output in German. Now they've got those in English or French or whatever language you happen to be using. So there are lots of wee incremental changes always going on. They also make a demo version, which limits what you can save, but you can use the demo version to do good work. There's nothing to stop you downloading the demo version, which is free, and using it to get used to this piece of software and have a play with it. If you go to Google, you will find thousands of examples of Lochmaster layouts, Lochmaster projects, Lochmaster circuits. There's an awful lot of it out there, which is good news, because it means you don't always have to start from the beginning. And maybe something there that's close to what you're thinking about doing, and you can take it from where you want to go. So that's me introduced what it is. Well, let's actually talk about what it really actually is. It's for doing strip board layout and design. Veroboard, as we often call it, strip board is the more generic term. You can also do strip board planning. You can do perf board planning. Now, a perf board is a strip board that doesn't have strips. Each of the holes has just got a little collar of copper round about it, and you join the dots vertically and horizontally to suit yourself. You can plan for that on here. There's perf board layouts come with it. And also breadboard. If you want to design something that you're going to put together on a breadboard, on the standard breadboards that we've all got lying about, that we've all used, you can do the planning for breadboards on here. And I've put PCB planning because you could make a board that's got no holes in it, put the components that you want on it, and then add individual strips of copper from each pin to the next pin and from there to there and form a ground plane and all that. But that would be a wee bit like using a spreadsheet for word processing. You're not using the proper software for the job. There's better software for some of these other jobs. So kind of while we're at that, having explained what it is, let's just talk about what it isn't. It's not printed circuit board design. There's a couple of very good products out there already. KiCad, which is free. Eagle. Now, Eagle was a great printed circuit board program up until about version 7. And then Farnell took it over for a couple of years and didn't know what to do with it. And then they sold it to Autodesk, the AutoCAD people. They've now got it. They've moved it to a subscription model. So nobody's using Eagle anymore. Everybody has moved on to KiCad. However, there's a third option there, Sprint Layout, which is made by the same people that make Lochmaster. And where, if you're using Eagle or KiCad, you have to get all the ducks in a row to make it work. You have to start with a circuit diagram, and then you have to get the circuit diagram so that it's fully connected, so there's no pins left dangling, and your net list will make properly, and then you have to do a full net list, and then you have to map the schematic footprint to the component footprint, and all that good stuff has to work for KiCad or Eagle or CADStar or some of these full PCB diagram stuff. In Sprint, you can just say, I want a 20-pin chip, and I want a 25-pin D-type, and I want to connect that to that and that to that. It's like sketching in printed circuit board. So it's much, much easier if you haven't been through the whole design workflow thing for printed circuit boards. You just want to make a thing that connects 2 chips, 5 resistors, and a couple of connectors. Sprint is really, really good for that, and I recommend it to you. And same as Lochmaster, there's a free version of it there that you can download and play with for nothing, and to keep it up to date, and I really recommend it. EDA is electronic design and analysis. That's worrying about the current draw and the voltages round about the circuit and the frequency response and board diagrams, and this doesn't do any of that. It doesn't do schematics. For that, you need fritzing, which is a lovely wee tool. Used to be free. It's now a very, very small amount of money. I think it's about €12 or something to buy a copy of fritzing. It does printed circuit boards, breadboards, and schematics. It doesn't do Veriboard really. It doesn't do stripboard, but it does everything else. And lastly, if you just want to draw, you've seen I've put circuit diagrams up here before that are, and I'm not being immodest here, quite luscious. And I do my luscious circuit diagrams using Inkscape. Inkscape's a drawing program based on Python, and I recommend it to everybody. It's a brilliant thing. So let's do the tour of Lochmaster. Open it up, and there's what you get. There's a board. It happens to be the 9-strip 25-column Veriboard that we use for the pocket money projects. There's a dialogue open, and you can see there's lots of buttons round about, and there's a menu. Now the menu I'll leave alone, because it's if you're actually manufacturing your own components, then the menu is useful. If you're generating your own boards, the menus are useful, but you really don't need the menu for 90% of what you do with Lockmaster. Everything you really want to do is in those buttons round about the edge, so we have to know what they're about. Up at the top, left-hand corner, there's the main pointer, and you will go there a lot. So much so that every time you press the escape key, it takes you to the main pointer. The escape key is the top left-hand button on your keyboard, and that pointer is the top left-hand corner of your diagram. So what happens is every time you want to go back up to the top left-hand corner and grab the pointer again, you just press the escape key. Below it, there's a zoom, and you don't really need the zoom, because if you've got a mouse with a scroll wheel on it, then the scroll wheel will zoom you in and out naturally all the time. So you very rarely go near the zoom, but it's there if you need it. Then we get the usual file stuff. New file, open a file, save a file, print a file. There's nothing there that's to run down 2 stairs at a time for. Anybody that has used software has done these things. Then we get to the clipboardy type things. You want to copy, cut and paste, the usual suspects, delete an object. What happens in Lochmaster, like all Windows software, you pick objects. You click on something and handles appear round about it, and that's the object that you're now working with. Now, if you put a new object in, let's say you put a resistor in, then it wants to know the name of the resistor, the value of the resistor, the orientation, whether it's in the bill of material, and all this good stuff. So it puts up a little dialog box to let you fill in all that stuff. But if you're putting in 5 pull-up resistors, for example, they're all the same. So rather than fill in the dialog 5 times, you put the first one in, and then you just press duplicate. And when you press duplicate, it just makes another one. Same value, same orientation, same everything, except for if your previous one was R3, this one's going to be R4. And it'll just keep adding resistors or capacitors or whatever it is that you're adding to your circuit by using that duplicate button. Saves a lot of time. You can draw on the surface here. You can draw your own boards. You can draw your own components using rectangles, lines, text, regular polygons. Thank God for that. If you think about an Arduino Uno board, it's very nearly a rectangle, except for there's a couple of wee cutouts in it. You can just draw it with that random polygon, fill it in blue, and you've got an Uno, and then all you need to do is add the connections to it. Really, really trivial. If you don't have a component, you can make one in a few minutes. These are the electrical. So far, we've done the filey stuff, we've done the clipboard, the copy and paste stuff. We most recently did the drawing-y stuff, and now we're at the electricity part of the board. It's VeroBoard, so I need to be able to add links, and I need to be able to put slots in it, cut the track, split the track. I had to be able to add components, component pins, and component leads, and I have to be able to add blobs of solder to it, because that's what you do with VeroBoard. Also, you can add a hole. If you want a hole right through your board for mounting it and you need to drill it out there, then you can put a drill hole in. And you can make signals, a named signal, which you need to do because we don't have nets. There's no net lister with this. I'll explain when I do a demonstration, when I do a wee demo version in a minute. Lastly, if you have a printed circuit board or an EDA circuit system, then it'll include electrical testing, design rules checking. And this has got very, very basic checking. It's got a little electrical continuity tester. If you click that on a track, it will light up all the things that are connected to that track, so you know whether or not your ground is connected to that wire or not, or whether or not your chip's got an earth and all that sort of stuff. And also your board needs an origin, and each component needs an origin. It is good discipline to give everything you're working with an origin, usually pin 1. There's lastly a couple of buttons to let you look at how you look at the board. You can look at it in colour or in black and white. You can flip the board over and look at it from the B side. So you can have components on both sides of the board. You can have resistors and capacitors and chips on the component side of the board, and then you can flip it over and have SMD devices soldered between tracks on the copper side of the board. You can look through the board so that you can see the board from above. You can X-ray the component so that the board's either got a 3D picture of the component or it's just got an outline, and you can X-ray the board so you can see through it. I'll show you all of these. The last one there with the tracks is, if I press that button, while I hold that button down, all the tracks that aren't in use light up green, so I can see where I've still got options, where I can still put things, what tracks I've still got to use. The show signals and potential, remember I said that you can name a signal. If I've named a signal, that'll let me see what signal it is and what it's connected to. Again, I'll do that in the demo. Lastly, if you're making your own components or you're making your own board, then this is more of the drawing tools. Show me it in colour, show me it in black and white, chamfer the corner, radius the corner, make it a sharp corner, the fill colour and the outline colour, and aligning things vertically and horizontally and generally. These are editing tools for a drawing, as opposed to the drawing tools, which were drawing tools for a drawing. And so how to use it? I thought the quickest, cheapest and easiest way to use it is to run through a quick demo. So I'm going to make Pneumatic Man Plus. Pneumatic Man was a little circuit that Davey did, 10 years ago now, whereby a 8-pin pick rattled a relay occasionally. And on the end of the relay, you attached a little figure of a guy with a pneumatic drill, so they would occasionally be seen to be drilling the road. As an animation for putting on roadworks and basically just adding a little bit of colour. That is basically Davey's circuit, except for I've added VR1 and R2. And what I'm going to do is make it that on Davey's circuit, J1 is the trigger input. You send a signal in there to make it work. What I'm going to do is make JR1 be a mode switch. So you can make it either triggered on J1, or you put a jumper in and it works autonomously. And then VR1 changes either the speed or the frequency of how often he does it. So it's just basically a software change, plus I'm adding those two components. So I've scribbled my circuit out on that well-known CAD system, CAD. As you notice, it comes with special fibrous output devices called sheets of paper. And the first thing I've got to do is look at how many nets I've got. Now, a net is a bunch of stuff that's all connected together. There's a net there. There's the 0 volt net, which connects the 0 volts of the supply, C1, C2, the regulator, C3, the jumper, the trimmer, the chip, and the transistor. They're all connected to 0 volts. There's another one, that's the 12 volt net. Right. There's a third one, that's the 5 volt net. The output of the 5 volt regulator is connected to the chip, to 2 resistors, and to one of the decoupling capacitors. And lastly, there's 3 or 4 other wee nets that have got 1 or 2 components on them. Every time there's a net, there's going to be a piece of copper for that. So I have to make sure that I know how many nets I've got and what's on them. So on a piece of paper, or in this case on a PowerPoint slide, I scribble my 9 nets. I've given them each a name. I've worked out how many nodes, how many things are connected to each net. And just because I'm me, I've put the names of all the things that are on each net so that I remember what this base net, it should have the Q1B on it, and it should have R3, the right hand side of R3 on it. So yeah, that's fine. So to Lochmaster. Now, it comes with a dozen or so LMB files, board files, but you can add your own. It's the work of 5 minutes to add your own. If you look underneath the dialogue there, you'll see the pocket money kit Breadboard that we've been using for pocket money kits in the past. I've made my own version of that, which is the small Breadboard with skirts, which is the one that I'm selected. When I click on small Breadboard with skirts in the board layout dialog there, it brings me up a model of the Breadboard with skirts. And that's the same Breadboard, except for I've given it ½ inch of space round about. And the reason that I do that is if I've got a connector or a potentiometer that hangs off the edge of the board, I'll be able to see it. If you make it tight to the edge of the board, you put a connector on the edge of the board and you can't see where it goes. It makes your drawing look cut off. You'll see it when I start to put components in the board. There you are, look at that. See that 12 volt connector over at the left? How that hangs over. Whereas if that board stopped there, you'd just get the edge of those 2 brown blobs and it wouldn't make much sense. Similarly, the regulator hangs over. Now that circuit is more or less exactly laid out the same way as the schematic diagram that I did on the piece of paper. Signal comes in on the left, capacitors, regulator, the 2 pull-up resistors, the trimmer and the jumper, the PIC chip, transistor, and an output to the relay. So that's pretty much identical. And all I've done there is went over to the left-hand side. There's a library of components. There's resistors, capacitors, diodes, transistors, voltage regulators. You can add your own libraries. There's my own Lochmaster, and as you can see, it's got Chinese modules, Adafruit, AliExpress, Arduino, Atmel, Chic stuff, Merg stuff, PIC chips, stuff from Rapid, stuff from Radio Spares, stuff from Farnell. You end up, if you're using a component more than once, you make the component for Lochmaster, and then you've just got it. You can always add it to a printed circuit board layout. Now that layout, a lot of people use. I tend to prefer to do that. By making things see through, then it's easier to see what's going on. I've picked up the continuity tester and I've touched the top track. The top track is the 12 volt line. And the 12 volt line has got the 12 volt connector, C1, C2, Reg 1, and relay 1. Now I've put a little red dot. That little red dot isn't Lochmaster, that's PowerPoint. I simply put red dots on there to let you see them, to let you see what I'm doing here. I'm making sure that that net matches the net in my net list that I made. There's the 0 volts. Remember, the 0 volts had 9 components on it. I had the 0 volts in C1 and C2 and C3 and the regulator and the VR1 and it's got the 9 dots corresponding to the 9 components, so I can check that my circuit is correct electrically doing that. And that's fine. But what I'm now going to do is what Davy did when he was making the Pneumatic Man, which is this. There's a lot of space there, and a lot of it's not used. I want to improve that. So what I'm going to do is this. I'm going to move all the connectors over to the left-hand side. I'm going to replace the trimmer with a twiddly pot and put the twiddly pot over to the right-hand side. I've taken the resistors and capacitors out and I've replaced them with SMDs, so that I've got SMD components in that circuit now. So that'll make it smaller and tighter. And also the mode thing, rather than have a jumper on the board sticking up, I've made the jumper be a 90-degree jumper, so I can put a jumper on the end of it or not as I see fit. So that's my improved Pneumatic Man. And I'm now using half the board. So that means that I could cut the board in half and make 2. Or if I wanted to put something else or some other improvement on the other half of the board, I've got a lot more board left. If I go here, I've pressed the green button to show me the tracks that I haven't used. And there's what I haven't used. What I'm going to do next is you put in some splits. You'll notice the splits that I put in are very narrow. Now, the reason that is, most people, when they're splitting vero board, they do it with a 5mm drill or a spot face cutter, and you put it into the hole and twist it, and it digs a hole round about the vero board hole. I tend not to do that. What I tend to do is use either a scalpel or, you know, the pin vise things, one of those with a little carbide cutter in it, and I cut little thin strips between the holes, like that. By doing that, I can cut strips all the way down there, and I can have half of that board back. Now, when I press the green button, it shows me that half of that board isn't in use. And at that point, I can start and build that board. I know where the links are, I know where the splits are, I know where all the components go, I know that it's electrically connected, that it's right, and so I can start and make it. It's taken me an hour out of my busy life. Now, I didn't build it because I don't need a Pneumatic Man, but what I did do is looked up. That incredibly good-looking fella is giving the talk on Charlieplexing last year, and we had an 8-pin pick, a 7805 regulator, and 12 light-emitting diodes. And using exactly the same techniques that we just did, I did that design for the Charlieplexer, and then built it, soldered it up, and it works a treat. I am totally confident that if I've used Lochmaster, that it's going to work. I don't have that thing that you sometimes have with strip board, that you think you've put things in the right place, you think you haven't done anything, switch it on, and either nothing happens, or worse, something gets hot. Never happens with Lochmaster. I've been really, really lucky with it. So moving quickly on, it'll also do breadboards, remember. So there's a breadboard design. You recognise that style of breadboard. That's the standard breadboard. It's got a nano. There's a Chinese module 7-segment display. And again, that unit doesn't come with Lochmaster. I knitted that one, took 5 minutes. And there's the wee ultrasound module. that you can buy from China, again, knitted by myself in a few minutes. And you can see where the connections here in green and yellow and red and black are very easy to follow and very easy to trace, and you can do a lot of logical troubleshooting without actually stripping wires and doing all this good stuff on the bench. You can do this on the laptop, sitting by the fire, and then when you go to start and do it, everything's set out for you. You know where you're going. You know what the tricky bits are. Now, we were talking about perf board last week, and there's one of the perf boards. I use that a lot. It comes from Farnell, costs about £1. Each of those rows is just set right for a normal 0.3 pitch chip. All the standard pick chips and op amps and everything that we use will fit very neatly in that board. And I use that sufficiently often that I made a Lochmaster version of that board. Now, there's a very subtle wee thing here I want you to look at. If you look at the nomenclature, the lettering in that board, the A, B, C, D, E, F at the top goes from right to left. Whereas on my board, the A, B, C, D, E, F goes from left to right, because that's me on top of the board looking down through it. I'm seeing the copper from a reversed image. Now, you maybe not catch the fact that the stripes going down and the stripes going up have also swapped when I turn that over. But the lettering certainly has. If I go back again, you'll see that the stripe coming down is to the left, and over here, the stripe coming down is to the right. And this came up in the conversation at the 65 Club last week, when people were saying that one of the big problems with a layout is you're so used to looking at the layout from the top. When you go underneath it, everything's reversed. Everything's backside foremost, and you can't remember where things are and where the wiring goes. This is that same problem. When you've got a Vero board like that, you have to remember that when you flip it over, left becomes right and right becomes left. Now, that board I've used for a couple of things. There's one. That's the standalone level crossing. About 5 or 6 years ago, Davey and I were talking about making a standalone, one-size-fits-all level crossing. And that was my version of it. Right through the middle of it, you'll see a railroad track. That's just a component I made up to put on that board. The chips there, the ICSP connectors, left and right photodiodes, and left and right laser totties. Now, those little laser modules, we don't actually have a component for those. I had to make a component up for the little laser modules, but again, it only took 2 minutes to do. Built that, got it working. There it is built. And there it is working, although there's not very much to see. But that's the sort of level of complexity. Up, maybe going above that, I would start looking at a bigger board, but we'll talk about that in a minute as well. Couple of things you should know about Lochmaster. First of all, components can be stretched, which you can't do with a printed circuit board layout. For example, there's a 7805 regulator. And if I've got a 7805 regulator, I can use it over 5 rows of Vero board. I can put the input up one and the output down one, so that I've got 2 extra rows in between. You can't do that in a PCB. If you're making a PCB layout, it'll only put the 3 holes 0.1 of an inch apart, and it won't let you do tricks like this. All right. Secondly, track cutting. You can cut tracks on the hole. The top one's cut across the hole. And if you see when I do the electrical checking, when the electrical checking comes to a split, it stops. As far as electrical checking is concerned, the track on the right there has got nothing to do with the track on the left. They're 2 separate nets. You can do the cutting between the holes, which is what I've done in the middle track. In the bottom track, I've done the same again. I've cut over the hole this time, but put a component over the hole, an SMD resistor. If you want a new component or a new library, It's as quick as using a drawing program. It is trivial, like a simple kiddies drawing program. Very, very easy. The things that go against it, there's no schematic capture. You've got to do your own schematic capture. There's no doing the net listings. You have to do it yourself, but you saw me doing it a minute ago. It's not hard to do. It won't produce a bill of materials. You're on your own. I've just said that components can be stretched. They can also be stretched beyond sensible limits. I could have made that regulator go 9 components across. Now, in reality, I could do that with putting wires on extending the legs of the regulator, but it'll let you do stuff that doesn't make physical sense. You only get basic design rules, which is that little checker to check that each track's connected to each other track. It'll only output prints to the printer, a JPEG of the board, or an HPGL plot. HPGL is Hewlett-Packard's graphic language, which was used 100 years ago. I used to use it to make maps when I was a surveyor back in the 1970s and 80s. It's an ancient HPGL language. They haven't upgraded that. SMD, it'll do SMD capacitors and resistors. There's no SMD transistors, diodes, chips. You have to do your own. Doesn't take long to do them right enough, and you can add them to the library. But if you're going to do that, you've got to do that. And using it isn't always entirely intuitive. There's a couple of wee things that once I've showed you them, they make sense. But until you're first doing them, they'll just frustrate you. If you're working with a right-handed mouse, then keep your left hand in the escape key. That way, when you want to stop doing what you're doing and go back to using the pointer, you just flap your left hand, it presses the escape key and gives you your mouse back. Because if you start adding text, it'll keep adding text until you press the escape key. If you want to add a resistor, it'll keep moving that resistor about until you press the escape key. So pressing the escape key becomes second nature. And if you didn't press the escape key and you've made a horses of it, then you've got an undo key. Press the undo key, it'll save your life. If you're going to move a component, then it makes really good sense to put your mouse inside the component and then move it. If you just press the move option, then what will happen is the component will move relative to where the mouse was when you started moving. So if your component was at the bottom right-hand side of the board, but your mouse was in the middle of the board, if you try to move left, you'll go as far left as the mouse will allow you to go, and then it'll stop because you've reached the origin, you can't go past it. So it's always a good idea to put the cursor in. The other thing is, people, if you hold the shift key down, you can move things really, really finely. 1/100th of a row, 1/100th of a hole. Very, very fine motion as possible. But it doesn't work until you've got it moving. So if you want to move something, if you hold the shift key and start moving it, nothing will happen, it will jam. If you start moving it and move it 1 or 2 spaces round about and then press the shift key, then suddenly you've got fine control. Press the control key, suddenly it'll snap to things, but you have to get it moving first and then press the shift key. I've already mentioned that you've got to reverse number, turning things over, everything gets reversed. Think about your layout, looking at the top, it's different from looking at the bottom. Putting the skirts round about it makes it much easier to see components that overlap, go over the edges. The splits don't need to be over the holes. Now, what I've found that sometimes if you split a track and then start messing with it, if I put a split in a track and then make it bigger and make it smaller and try to tweak it, it'll stop being a split. So when you put a split on the track and you're finished playing with it, check that it's still a split. Use the continuity checker to make sure that split's still working. Because if it stopped working, it can confuse your electrical checks for the rest of the board. And the last thing that I want to bring to your attention before I finish is this. Version 0.1 of the Raspberry Pi. Before the Raspberry Pi was an ARM chip, and a Broadcom system on chip. It was an Atmel 1284 and some basic logic and an EEPROM. And that was the very first layout of the very first Raspberry Pi prototype, Lochmaster 3. Any questions, any comments?